Well, good morning, dear student. Welcome you once again in the class of thermodynamics. In the previous class, we have learned the some basic terminologies. That is the what is meant by thermodynamics, what is the system, surroundings, and universe. And we have seen the systems and its three types. That is open system, and the closed system, and isolated systems. So, friends, we move further today and we'll see the thermodynamic variables. In this year, dear student, we are learning the classical thermodynamics. So, means we are dealing with the microscopic properties. What we're dealing with this year, we are dealing with the microscopic point of view. Okay. So, dear student, so what is meant by thermodynamic variables or thermodynamic coordinates? We also call it as a state variables or function of state. So let me call it state variables. State variables or thermodynamic variables. What do we mean by thermodynamic variables? Or you can also call it a function of state. Otherwise, okay. So what is meant by state variable, thermodynamic variables? As I already told you, we are studying the classical thermodynamics. So we are studying the microscopic properties. So these properties may be the pressure, volume, and temperature. So what is the state variables? What is thermodynamic, or we can say thermodynamic variables? What does that mean? What do you mean by state? So first, the question may rise in your mind, what is meant by state? Okay, so you see here the this word. So you may think that what is meant by state? Okay, so dear student, as simply yes, yes, state means a particular condition. What I'm saying, a particular condition of system. Okay, so let me give you an example. Say if you take a cube of ice, so this is ice. What happen when you hit this ice? Then what happen? It will be melt in the liquid form. Okay, it is in solid form. Then it will become the liquid form. Okay, then its phase it changes. So here you keep in your mind that phase is changes. In thermodynamics we call it is the phase is changes. So this is not a state. So what is mean by state? Let me give you again one of the example. Say similar to last time, take a cup of coffee. Okay, you put this cup of coffee on the table. Okay, then what happened? Initially you put this you poured some coffee inside the cup and the coffee was really hot. After some time you see that the cup of coffee is cold. After some time here it is hot and here it is cold. Okay, so means that the system, the state of system, here you just keep in mind the analogy and what I'm talking. Here is the state of the system, means a particular condition. Here is the this cup of coffee was hot and here after some time it is cool. So the system, the state of system is changes after some time. So you understand what is meant by state. State means a particular condition of the system. Okay, so you understand the state. So the state we have explained by the year, by temperature. Again, if you notice this, the volume, here is also volume and here the same is the volume. Here pressure may be the same. So here we have defined the state using the temperature, volume or maybe the pressure. Okay. So we need to now define state variables or thermodynamic variables or state of functions. So what is meant by thermodynamic variables or state variables? What is meant by state variables? We also sometimes call this is a thermodynamic coordinates. Okay. So somebody may ask you the questions, what is meant by thermodynamic coordinates. So you can define state variable same as the thermodynamic coordinates. So thermodynamic coordinates sometimes state variables. Okay. So what is meant by state variables? So here you taken temperature and volume to describe this system. Okay. So how to define the state variables or thermodynamic variables? Say we can say that how we can define the variables, the variables which are required, what I'm saying, required, the variables which are required to explain or say describe, to explain the state of system completely. Okay, then the system is said to be thermodynamic. Then the variables are said to be thermodynamic variables. So what is that? State variables means what? State variables, or we sometimes we call it a thermodynamic. This is thermodynamic variables. Okay. So what is my thermodynamic variables? The variables which are required to explain the state of system completely by pressure, volume and temperature. So you see the pressure, volume, temperature, these are the macroscopic properties. These are microscopic parameters. Okay. So you got what is meant by state variables. So you need to explain what you need to explain. You need to explain this system. You need to explain this system using these parameters. So you explain this. If you need to explain this cup of coffee using the some variables temperature, volume. Okay, so we have defined that the variables which are required, which variables temperature and volume required to explain the state of the system completely by the pressure, volume and temperature. Okay, so it is called the state variable. You got it? Okay, if you see this microscopic properties, or say this is the variables like pressure, volume, temperature. Using this we can explain the system completely. So here these state variables are not dependent, they are not independent. Okay, here I can say that thermodynamic 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 variables are not independent, are not independent. Okay. They are they are they are related they are related by following equation. They are related by following equation. What is that equation is? That is f of p means pressure, p means volume, and T means temperature. So here you say that thermodynamic variables are not independent. They are related by the following equations. This equation. So here this pressure, volume and T are interdependent. Okay. Interdependent. Interdependent. Okay. PVD are interdependent variables. Oh, if you need to explain the equation of state of ideal gas, if you need to explain the ideal gas in case of ideal gas, so what will be the equation of state? So you know that is PV is equal to RT. P is okay. You got it. Then, in case of real gas, in case of real gas, the equation for the real gas is P plus N square V square into V minus NB is equal to RT. Okay, this is in case of the real gas. So you understand what is meant by thermodynamic variables here. Thermodynamic variables simply means the variables which are required to explain the state of a system completely by pressure, volume and temperature. Okay. Then we know what is meant by state. State is the particular condition of the system. So you got it. So what is the variables? So here you need to explain the system, the thermodynamic system, completely using the temperature, volume or any of the things. And you see that these variables are not independent. They are interdependent, interrelated to each other. So we have these equations from they are related to each other. So in equation of state, in case of ideal gas, P is equal to nRT, and in case of real gas, this is this one is the equation. So dear student, state variables can be divided into two parts. That is, first one is the intensive. First one is the intensive, and the second one is the extensive. Okay, first one is the intensive and extensive. Intensive variables means which variable? Those variables are those variables those variables independent of mass. Independent of mass. Mass, or say here I'm calling instead of mass I'm calling size. Okay, and in case of extensive means those variables which are proportional to system size. Variable are proportional to system size. Okay, so how you can divide the thermodynamic variables or this state variables into two parts: intensive and extensive, depending on its independent of size, and extensive is proportion of size. So what is in the independent of size? If you take uh, water in a glass and the glass is full, if you pour this water in the cup, then if you see here the density, is same. When I pour into the this cup, density is same again. So here I can say example of extensive variables is density. Okay, again here the say the temperature of this water in the glass at room temperature. Here if I pour here again, the temperature is same. So second will be temperature independent of size. So temperature and density is not dependent on the size. So move further. Extensive here those variables, they are proportional to system size. System size means what? If I take the glass of water, okay, then say if I pour this glass of water into another glass, okay, this is the half fill. Okay, this is the half fill, and this glass will be again same. This glass again will be half fill. So you see, this glass initially was full, and I pour this glass of water into another glass. So this both glass is half. So here you see the system. Say this is system, and this system, then the size of system is changed. Okay, the size of system change. So what is the example of the extensive or the volume? Say volume or area. Okay, volume or area. These are the example of the extensive thermodynamic variables. Okay, you got it.